All right, so on with the exam review. I'm on page 6, Algebra review. So we have to know what are like terms. They are terms that have the same variable, so that variable means letter, and the same exponent. Okay, so x squared and 3x squared, these are like terms because they have the same letter and they have the same exponent. But if I had something like 3b squared, even though they have the same exponent, these are not like terms because these letters are different. And the number in front just tells you how many of them there are. So that's not a like term. All right, so we want to collect like terms. So when I do this, what I do is take a look. First, I have a 5x, so I'm going to look for all terms with an x in them, and the exponent is 1. That doesn't have any x's. This has an x, but it's squared. This does not have any x's. And you have to make sure you take the sign in front because that tells you what to do with that number. All right, so I'll reorganize these before I do any math with them. So now I want to look and say, okay, here we go, a positive 5. And what you do is use a different line. I'll use a little scoop. This one has x squared. This one we have a negative 7, and that's all I have left. So I have to use up a plus 5 and a minus 7. And now go ahead and look and see my last terms here. My last terms are a negative 3x squared and a positive 9x squared. So now I'm going ahead and do the math with the like terms. So my like terms here are 5x plus 4x. So you do the math with the numbers in front. 5 plus 4 is 9, and they have an x there. So the x stays the same. There's 9 x's. Now I'm going to take the next group of like terms. Positive 5 minus 7. If you don't know, if you're not quite sure, do it on your calculator. You can do it on a number line. We're left with negative 2. And then my last terms are this negative 3x squared plus 9x squared. So you're really just doing the math with the numbers in front, and you're putting the x squared after because that stays the same. So if I have a 3, but it's a negative, okay, and I want to add 9, I get 6. So that comes out to a positive 6. And there I have collected my like terms, and I can do a double check and just see if any of these are like terms. They're not, so I can't simplify this anymore. We need to make sure we keep track or keep the sign in front of the term. Okay? Because that tells us what to do with it, whether to add it or subtract it. Keep sign in front of the term. All right, so let's take a look at this next one and see what we've got in terms of our like terms. So take a look. I've got a 7x squared. This is not an x squared. This is not an x squared. This one is an x squared. So I could go ahead and do the math with that. 7 plus 4 is 11x squared. Now I could take my x terms. Oh, look at that. I don't see any other x terms. Therefore, it's just a plus 2x. And now, I'll use squiggly lines, negative 4 minus 3. I'm going to write that one down just to make sure I don't do anything wrong. These ones have no other like terms, so right here on my calculator, I put a negative 4, I subtract 3, and I get negative 7. And that is my final answer. I cannot simplify that anymore. Now, we're going to go on with adding and subtracting polynomials. Okay? The difference here is we're going to have a bunch of brackets. So to add and subtract polynomials, we need to remove the brackets and then collect like terms. Remember, this is something we did from the previous page, page 5. When we subtract, we must change the sign of every term in the second bracket. So what that means is this term right here, this sign applies to every term. Right here there's 3 terms. 1, 2, 3. So that addition applies to every single one. Now, when it's the first set of brackets, really we can just take those off. There's nothing extra to do with that. So now here, since this is positive, it means I'm adding 9x squared. Here I'm adding negative 8x, so those are different, so it's a minus 8x. And adding a positive 6, they're the same, so that's staying. And now it's the same question as it was before in the above. Collect my like terms. So here's my x squared. And I see only 2 of them, so I'm going to do 3 plus 9 is 12. Well, and that is an x squared term. So now I'm going to go ahead and do the next one. The other thing that is often useful is a highlighter. Okay, so I want to do my x terms. Notice that I'm also highlighting the sign in front. All right, so here I'm doing a positive 3 and I'm minusing 8 or subtracting 8. And if we do it in the calculator, it is 3 minus 8. We get negative 5. Now that's the math with the numbers, but we can see this term as an x. And then we have the last part here. Different colors again could also be useful. So there we go. Notice that I'm taking the sign in front. So I'm left with negative 5 and a positive 6. So there's negative 5 and I add 6 and I get 1. And that's because 6, the positive number is greater by 1. So that's why I have 1 left over. Okay. And do a double check here. This is an x squared term. This is an x term. That doesn't have any variables. So that is simplified as much as it can be. Now when we get to a negative being between or in front of a bracket, this can get a little bit more complicated. Again, we have to keep track of our signs. That first brackets can just be taken off because it's not really doing much but grouping those 3 terms together. Now we have to say we're subtracting 3x squared. But this negative or subtraction applies to every single one. So I did that first term, now I have to do the second term, but this is minus negative 4x. Now, I mean, I could write it this way and put in an extra step, and it would look like the page before when I had always double signs. And if you want to do that, that is fine. It's not a problem. We can do that little bit extra, and it's not really extra. It's just showing all your thinking. So here I have a negative and a negative, and we said if they're the same, then it's a positive. Here I have a negative and a positive. That's going to stay negative. So now that's one way of making sure that this right here, this sign, has been applied to every single term. Okay. Now we go ahead and let's collect like terms. I'm going to use my highlighter. I have an x squared and I have a negative 3x squared. So let's do those. Now if there's not a number in front, it means that there's a 1. Because if you write it, it means that there's 1 of them. So I have 1 minus 3. 1 minus 3 is negative 2. But that's with an x squared term. Now I'm going to go ahead and do my x terms. All right, so let's go ahead and look. And notice I'm picking the sign out in front. Ooh, a negative 4 and a positive 4. Well, negative 4, positive 4. Let's take a look at that. Negative 4 plus 4, 0. So there's none of them left. So that is actually 0. And then my last term. My last terms are my constants. They don't have any kind of variable. So I have a positive 2 and a negative 7, or subtract 7. 2 minus 7 is negative 5. And there I'm done. It might look like I've forgotten about the x term, but that just added up to be 0. And there you go. That's your final answer. And remember, pause this video at any time and try and finish off the question on your own, because that's the only way that you'll get better. All right, now multiplying monomials. So this is where we don't really have to worry about like terms, but we do have to worry about our exponents. So in multiplying monomials, you multiply the coefficients. Coefficients is a fancy word for a number. So I always say I do the math with the numbers in front. And then I have to, when I multiply the variables, I need to add the exponents. Okay? So let's do the math with the numbers. Now I'll split this first one up so that we can, I'll explain exactly what I'm doing. So right here, if you want, I'm going to throw in a positive sign just in there. And I'm just going to say, hey, look, I have a negative and a positive just so we can look at the signs. And then I have a 5 and a 3. And then I have my x's. I mean, this is way more expanding than you need to, but I want to make sure you guys see what I'm doing. So the first thing is I look at the signs. Well, one's a positive, one's a negative. So that means I'm left with a negative. And then I'm going to do the math with the numbers out in front. Well, that's just 5 times 3. When you don't have anything in between the brackets, it means multiplication. So if you need your calculator to do that, go ahead and go 5 times 3, and you get 15. Now, with these x's, this is x squared and this is x to the power 3. So the shortcut would be just to add the exponents. And you go ahead and do that, and that's negative 15x to the power 5. But I'm going to show you one step past that, just in case I can show you what this means. So all this stuff out in front, the negative 15, is fine. But if I do this x squared, well, x squared really means x times x, because there's two x's. And x cubed means x times x times x. That means there's 3 x's. So there's my x squared, there's my x cubed. Well, together, how many x's do I have? 1, 2, 3, 4, 5. And that's why your exponent is 5. And that's where your final answer comes from. I don't have to do all that work for these ones. So here we can do our 2 times negative 4. Okay, 2 times negative 4 is negative 8, because these are different signs. There's our negative 8. And I have x times x. Well, x times x, how many x's are there? There's 2. And if you want, you can imagine a little exponent of 1 there. So you get x to the power of 2. There's your simplification. And now our last one. There's no number in front. That doesn't mean it's 0. It means it's a 1 because I've written it once. So the number there is 1 times 4. It's just going to be 4. And then I have x squared times x. Well, x squared times x looks like that. So really, there are 3 x's there, and you're left with 4x to the power 3, or 4x cubed. All right, so let's move on to page number 7. So page number 7 is still the polynomial review, or monomials and polynomials. So now we have a combination questions where I have a monomial and a polynomial, which just means more than one term. So multiplying monomials by polynomials, there are lots of big words. We can make a rectangle and multiply just like you're finding area. So I can do this with both ways. I did it 2 different ways before. The other way that we do it is just say that this term has to multiply by each term. So here you have a term, 2 terms in this bracket and only 1 term here. So we can do it. Okay, so there's this one, and now I need to apply it to the first term. And I also have to apply it to the second term. So if I have this sign right here, I can put it out in front if you want, okay, because that's that sign. And now I have a negative 3x squared, and I have my term 2x right here, if that's how you want to do it. Okay, so now we do the negative 3 times the positive 3, which is negative 9. And then I have an x squared times an x squared, which means I add the exponent, so it's 2 plus 2, and it's x to the power of 4. Okay. Now here I can put my sign that was down. I'm going to get rid of these brackets. I have a negative, well, I'm not going to get rid of the brackets, so I'm going to do the math in here, and then I will get rid of the brackets. Negative 3 times 2 is negative 6. And I have an x squared times x, which is x to the power 3. And this is not good form to leave it in this. This is not simplified. This first term is done, though. So I'm just going to rewrite it. Make sure you rewrite everything down that you didn't use or you don't change. And a negative become a positive, and I'm left with 6x cubed. And that's done because I cannot add these terms because they are alike. They are not like terms. All right, so now with this one, I have 1, okay, or a single in front of brackets with 3 terms. So that means I have to apply this one to the 3 different terms in the other bracket. So I'm going to write x squared times 5x squared. Now I'm going to bring the sign down, and I'll put my x squared, which is here, and my 3x. And then my sign, and I have my x squared, and I have the 7 right here. So I've brought my signs were in between my terms, and I've brought down whatever number is, or whatever is there after the sign. So here, the number's not going to change because the number in front is 1, and 5 times 1 is 1. X squared times x squared. X to the power 4 because I've added the exponents. Here, I'm not doing anything changing with the signs because they're both positive. The number doesn't change because there's no number in front of here. It's 1. And x squared times x becomes x cubed. And finally here, there's really nothing to change here. There's just a constant, the number 1 in front of here, so that's multiplying by 7, which is going to be 7x squared. And you'll notice when this happens, when you multiply, there's 3 terms in this bracket. That means there's 3 terms in the end, because this one is multiplied into it. Same thing goes here. 2 terms in this bracket, but we're multiplying, so we end up with 2 terms in the end. Okay. Now, the next part, solving equations. We played that mobile game that helped us do this. So we want to solve for x. Isolate is just a word for getting it by itself. So essentially we're solving for x, which means we want to get it by itself. So what we have to do is we need to get rid of terms. The way we get rid of a term is we have to do the opposite. Okay? Now doing the opposite will often get it to become 0 or 1. It just depends on whether we're adding and subtracting or multiplying and dividing. So we do the opposite to get rid of. So division and multiplication are opposite. Those are opposite. And adding and subtracting are opposite. So these 2 things are opposite. We have to remember to do the same thing on both sides, because this is what keeps our teeter-totter equal or balanced. We need to keep it balanced because the equal sign, right, is like this balancing point, and we need to keep our equation balanced. Looks like a little Inukshuk. Okay? So when I look at this right here, I want to get x by itself. I'm not going to worry about the fact that there's a 5 in front of it right now. First, I want to just get its term on its own. So I look at this negative 17, or subtract 17. I think, what is the opposite of subtracting? Well, the opposite of subtracting is adding. So I'm going to take a different color and say, hey, well, I'm going to add 17. But I need to keep it balanced. So whatever I do on this side, I must do on the other side. So there I've done the same thing on both sides. This is what's going to keep it balanced on the equal sign. So we're always doing that so that this becomes 0. So now I'm left with 5x, and on this side I have to do a little bit of math. 17 plus 3, that equals 20. Okay. So now I'm going to look at this and say, well, how do I get rid of the 5? I need to look and say, what's the 5 doing to the x? Well, in between here is multiplication. So the opposite of multiplication is division. So I'm going to divide by 5 because I want to get x by itself. And 5 divided by 5 is 1. But I better make sure that I do the same thing on both sides. So there I am dividing both sides by 5. And I'm left with 5 divided by 5 is just 1. So I'm left with an x, not 0. And 20 divided by 5, and look, it's still in my calculator. I'm just going to divide by 5, and I get 4. So I get x is equal to 4. And if you want, we can also do a little check on your calculator. I could take the 4 and put it in here and see if I get 3. So if I want to do a left side, right side check, I take 5 times 4, I get 20. I subtract 17, and I get 3. And I actually get the same number, which means I did it right. That's kind of a left side, right side check. So a left side check is what you do is you do 5x. This is what I did on the calculator. You should show your work. And you get 3. And there's your left side, and your right side equals 3. So left side equals right side check. You did it right. So let's go ahead and try this one. Again, I want to get x by itself, but don't worry about what's in front of it until the end. We take care of the addition and subtraction first. Kind of like opposite BEDMAS to a little bit of a degree. So let's write down the negative 2x. Let's write down the positive 7 or plus 7, and the opposite of plus is minus. So I'm going to subtract 7, and I'm going to look at this and say, okay, write down the minus 15, but I still have to put in that term right there. So I've done the negative 7 or subtract 7 on both sides. This becomes 0. Don't forget about that negative in front because you'll get a different answer. And here, do this on your calculator if you're not quite sure. So I have this button here, negative, positive. I can change that 15 to a negative or positive. Subtract 7, and I'm equal to negative 22. And now I look at this, and this is when I figure out, okay, well, what's in front here is a negative 2. So that means I need to divide by a negative 2. So I'm going to do that on both sides, and negative 2 divided by negative 2 is 1, but if you want to double check, you can go ahead and do that, and you get a 1. And this side right here, negative divided by a negative is going to be plus, and 22 divided by 2 is 11. And there we go. If we want to do our left side, right side check, let's do that. Negative 2x plus 7, negative 2 times 11. So what I've done is write down the left side of the equation. I substituted in what I think x should be, and now I go ahead and do the math. Negative 2 times 11, negative 22, plus 7, so negative 22 plus 7, and that equals negative 15, which equals my right side, and that is check. Awesome. All right, multi-step. So multi-step just means what it says. We will have to do a bunch of steps to solve for x. All right, so the first thing we're going to do is simplify if there's anything I can do. So if I look here, I see a 5x term and a negative 3x term. So I can do that. So I have 5 minus 3 is going to be 2x, and then I have a positive 7. I didn't change anything or do anything to the right-hand side. And now I'm going to look at this and say, oh, well, I need to get rid of this term. So to get rid of plus 7, I need to subtract 7. So subtract 7. I have my 21, and I'm going to subtract 7 on this side. And the whole reason I did that was to get rid of these ones, so that ends up being 0, 2x, and I have to do 21 minus 7, and I'm left with 14. And now here I look at this and think, I have a 2. I have to do the opposite. That's multiplying. So I'm going to divide, and I'm going to do it on both sides. So here I'm left with just x, because 2 divided by 2 is 1, and 14 divided by 2 is 7. And if you keep your calculator close by, I actually have the 14 on there, just divide by 2. You can see you get 7. Now this one is a little bit trickier in the fact that I actually have x terms on both sides. So that means I need to collect them together, all right? So it's like getting rid of it on this side. If I want to get rid of the 6x on this side, I have to do the opposite. And if there's no sign in front of it, then it means that there's a positive. So what I'm going to do is I'm actually going to subtract 6x from both sides. And the reason I did that was to get rid of it on the right-hand side. Whoops. I want to get rid of it on the right-hand side, and it will end up on this side because I'm going to do the math there. This one ends up being 0. So 4x minus 6x is negative 2x. On this side it ends up being 0 because even though I wrote 2, I meant to write 6. 6 minus 6 is 0. And I'm left with my minus 13. If I gave myself enough room, there was that other method that I was showing you guys in class where I actually put it underneath, which I think is really neat, but some of you didn't like it. But I'll do it right here just as a reminder. So I put it underneath what I need to do there, and positive 5 and negative 5 end up being 0. And here, a negative 13 minus 5, you can do that on your calculator. We have a negative 13 minus 5, I get negative 18. And I take a look, it's a negative 2 out in front, so I have to divide by whatever is out in front, and I have to do it on both sides. So I'll come over here, negative 2 divided by negative 2 is 1, but there's an x there. Negative 18 divided by negative 2, well, negative and negative is a positive, and 18 divided by 2 is 9. And that is the review for polynomials and solving equations.